Morning. Did everyone see the keynote? Was it good? Yeah? I'm gonna watch it later on. So, heroes and villains all have their origin story. Now, I don't want to compare me with a hero or a villain, but this is definitely my origin story. Because almost everything with I can track back to a moment in time with the ZX Spectrum. Good or bad, I guess. So I will take you on a journey, my journey, because when I did this presentation, it became a much more personal presentation. You're going to see a lot of things throughout my life that, well, the Spectrum made possible, I guess. But we're going to start with a little bit of history. So this presentation starts in the 1980s, or 1980 on the dot, in January of 1980. The Sinclair ZX 80 came out. Never had one of these, though. It was available in the UK for around £100. The same year, the VIC-20 and the TRS-80 came out. So that was kind of a nice computer, bunch of computers coming out that year. In 1981, the ZX81 came out. Did anyone have one of these? Yeah, a couple of you? I never had one back then. I have one now. Actually, I have a couple of them. It was available for £50 as a kit or £70 pre-built. In April of 1982, the ZX Spectrum was released in Europe. It was a best-selling British computer. It sold around 5 million computers. In August the same year, the Commodore 64 came out. It sold around 13 to 17 million, so quite a lot more. But the C64 was the second most popular computer in the UK. The Spectrum was number one. Now, the ZX Spectrum has clones all over the world. It had 5 official clones and over 70 unofficial clones. So if you combine all of that, you would get 13 million sold devices. So quite a lot there as well. Now, this brings us to 1985. And the second most important thing of 1985 in my life was that I saw Empire Strikes Back for the first time. Now, the problem was that I already seen Return of the Jedi. So, I mean, we're all talking about what order should you see the Star Wars movies. Well, let me introduce a new one for you. 465. That's how I did it. But the most important thing that happened in my life back then was, of course, I got my first computer. And you probably guessed it, a ZX Spectrum. I remember my parents bought it, and I connected everything up. My brother brought it home, and I wrote 10, print Jimmy, 20, go to 10, run. And this was my code. I made the computer do stuff. And this was a very defining moment for me, because this was the moment when I realized that I wanted to become a developer. I was 7 years old, and well, this is what I want to do with my life. And back then, you didn't bring out any cameras unnecessarily, but this is the only picture. I'm not sure if it's actually visible here, but down here, there is a ZX Spectrum. That's my sister. The ZX Spectrum had 15 colors. We're going to come back to that. But this is a black and white TV. So I guess I didn't have any benefits of that. But here's where I come into the story. My name is Jim Engström. I work for a company called Cab Group in Stockholm. Well, I live in Stockholm, but the company is in Örebro in Sweden. I'm a Microsoft MVP, and well, I've been writing code since 1985, I guess. And if you want the code for that 10 print Jimmy, it is available on GitHub, so you can get that from there. Now, back then, we didn't have any internet. Actually, I assume it existed back then, but it was not mainstream. So what we did have was these kinds of books. This was translated into many different languages. Was also, we had magazines like this one. And if we take a look, I mean, you can't maybe see it on the beamer here, but it was a lot of code that we typed out into the Spectrum, and we can run the app. And I mean, this, well, again, you can't see the code, but this one is fairly understandable. This one is a little bit more tricky to understand, perhaps. So this was probably the GitHub of the 80s. We were sending books and papers back and forth. Now, I did a version of this talk in Sweden, and there was a young guy coming up to me, and he was like, "Oh my God, your talk was awesome. I had no idea this even existed, that these kinds of computers. It totally blew his mind." This is my brother up here. He wrote reviews for a Swedish daily press newspaper for Spectrum games and Commodore 64. But Spectrum was a lot of Spectrum games in there. He also wrote code that you can, well, again, type into your Spectrum. But in the daily press, we also had community radio stations transmitting Spectrum games and programs that you can just record and then run on your Spectrum. So I guess that was our Pirate Bay, I guess, back then. But it kind of proves that this was very, very mainstream back then. Perhaps more mainstream than computers is today. Now, the years passed. I got a ZX Spectrum, well, we called it 128. I think its official name is Plus. I got a Commodore 64, I got an Amiga, and followed by PC. But I was very interested in this emulation stuff. So I started like dabbling with Amiga emulators and stuff like that. And I can't believe I'm actually going to show you this, but one of my first web pages that I made was about emulation. Yeah, it's totally in Swedish, but this was the page that I did. And apparently I thought that, you know, front page, this is something to brag about. Let's put a GIF in there. Yeah, so despite this, I got my first job as a developer in 1999, working with ASP. I'm actually not sure if they've seen that page before they hired me. I hope not. But kind of the interest of emulation was born already there. In 2002, the Xbox came out. That was kind of cool stuff, right? And it kind of, the idea of creating an emulator was born again. So I thought, is it possible to do an emulator for the Xbox? I did know a little bit of C++ or C, not enough in any way or form, but I found a guy that had created a port of an emulator called Fuse, and he had created a port called Pocket Clive, and that is for Pocket PC. And he just happened to be Swede, so I started talking to him, and he helped me understand what the things that I needed to bring in, and more importantly, the things that I didn't need to bring in. So working with that, I actually got it working on the Xbox. It looks something like this. Now, the XDK is not an open product. You had to have an hacked Xbox. So again, the dream of creating an emulator kind of died out again, and well, I never got anything released. But the emulator I'm going to show you is still called ZXbox, so that's the origin of the name. Also in 2002, the .NET came out, and I'm like, worked in ASP, worked in VB, we're going to go all in VB.NET. This is going to be awesome. And my colleague was like, no, we're not. We're gonna do everything we do in C#. No, you're not getting it. There is something called VB.NET. So we know VB, we should definitely go with VB.NET. And he said, well, what we're gonna do is, if we go the VB.NET route, we're gonna bring in all those old habits, those horrible habits perhaps, over to the .NET world. So we're gonna do a clean slate. We're gonna learn C#. So that's why I chose doing it in C#. Around 2006, XNA came out, and a version of XNA that could run on Xbox 360. The idea of emulation came back. I got to do this, right? So I talked to a colleague of mine, and he recommended this book. Anyone read this book? Programming the Z80 by Rodney Sachs. No one? It's an awesome book. So basically what I did was that I opened the book, I implemented the instruction. It is all about the instructions available in the Z80 processor. I turned the page and I implemented that function or operation. And then I turned, and through this whole book before I could actually run the emulator. But let's step back. What do we need to do to create an emulator? Well, the CPU can do things. It has a code, an opcode, or an operation code that does something. So these are assembly instructions. But don't worry, some developers kind of like shuts down as soon as you say assembler. Don't worry, we're going to break this down. Basically what it is that you have a number, it means something, it means that you can add something together, it means that you should move something in memory, whatever it may be. The ROM, we had different ROMs in different countries. Sweden actually had some special characters in there. So you could write an application that only worked for the Swedish version, for example, because you could have variables named with those special characters. Now, the problem with all emulations is that the ROM is usually you're not allowed to distribute the ROM. But in 1986, Amstrad bought Sinclair, and they said, you know what, distribute the hell out of this. We're fine with this. As long as you keep the Sinclair logo and all of that, you can't change it, but you can distribute it. So as far as I know, this is perhaps the only, but at least one of the few emulators that you're allowed to distribute. So let's talk about the inner workings. It has a lot of registers. It has all of these registers. So A, B, C, D, all of that, and then prime versions of these. So what does that mean? What is a register? Well, it is a byte. That's basically what we need to know about them. And you can also combine these, so you can get 16 bits registers by combining the two. We also have a F register. Well, it was actually on the other one as well. But the F register is a flag register. So it has a couple of signs, 0, 5, half carry, and all of that. And that sounds super mathy, but it's all documented very well in this book. So you can check, if I'm running this operation, how should the flags be affected? We also have a couple of more registers, the PC, the program counter, the stack pointer, and all of that. We're not going to talk more about those really. But basically, 8-bit registers and 16-bit registers. So the registers are implemented this way. Now, I said it was a byte. This should be a byte, but for some reason I did it with an int. I have no idea why I did that back then. I actually have a PR changing it back to byte, but well, let's just, this is the way it's implemented right now. It should be bytes. So it's an array of ints for the different registers. I also have some properties, so I can get access to those registers a little bit easier. I also have the combined ones, so it's easy to develop new functions. Now the flag register, you saw that it had a lot of different things for each bit. The flag register looks like this. So I have a bunch of bulls for each of the flags because it's easier to set it that way. Okay, so back to the CPU. So the program counter, a position in the memory. Once it's done, it's going to say program counter +1. And we're going to go to the second position here. And 78, what does that mean? Well, again, our trusty book will tell us. So the CPU, or the program counter, is pointing to hex 78. This is the binary representation of 78. And if you look in the book, it is this assembler instruction. So load the A register with the value of the B register. Okay, that's cool. So let's take a look at them in the book. So we have 0, 1, followed by the source register, and then the target register. I hope I got that in the right order. I think so. Yes. No, the other way around. The target register and the source register. So when I was doing this presentation, I realized that this could be optimized. I'm going to take a look at that as well. If we go down here, we can see that it takes 4 T states. We're going to come back to T states as well. But it takes 4 T states. And we can see down here that it's not affecting any flags at all. Cool. And if you take a look here in the matrix, we'll see that 78, it is loading the value from the B to the destination of A. So what I did was that I created a function that based on the register, I could get the value out from there. So it looks something like this. So I get the opcode and I got the position or the register from there and got the value out from there. So if you take a look here, and we got 78, we get a bit mask, so we're kind of just getting those parts. We're going to get back 0, 0, 0. And if you take a look in the book again, 0, 0, 0 is the B register. So we can use the opcode to kind of get out the registers that I want to talk to. So very simplified, this is the instruction, right? If the program counter is pointing to 78, put the B value into the A register. Cool. And then subtract the number of T states, and that was 4 according to the book. Now, there's a lot of registers, so that would would have to write this code 7 by 7 times. So 49 times I had to write this kind of exact code. And maybe you saw Mad's session in the beginning of I think it was Tuesday. The evolution of the language. So what I did was that I ended up doing something like this. So it's kind of like a little bit better. It's a little bit fewer lines of code. But I thought, there must be a better way. So in C#9, I could do only this. So I can use these nice case things, and I'm going to say, well, if it is 78 and it's less than 70, or, well, you get the point. But I still needed to do this 7 times because all of the different registers. And we know that we had the destination and the source already in the opcode, so let's do it even better. So this is what the emulator is actually doing. So for all of these different assembly instructions, we're doing the same parts, executing the same code. So what about the instructions? How many do we have? Well, we have 256 with no prefix. We have 78 with the ED prefix. 256 CB prefix, 85 with the DD prefix, and DD CB prefix 256. So this will leave us around 1,000 instructions that we need to implement. And the sad part is that we need to implement all of them for us to be able to actually run the emulator. So when it comes to timing, it is 3.5 megahertz running. We have 50 frames per second. That's a normal TV. And it means that it's 70,000 T states per frame update. It's actually 69,888 because it needs a little bit of time to actually render the content. And we need to do all of that in 20 milliseconds. That's basically what the emulator does, which is kind of insane when you think about it. So when it comes to the memory, we have a little bit of ROM, screen memory, a little bit of attributes. We're going to come back to that. We have a printer buffer, we have a system reserved, and then we have a bunch of memory that we can address. So all of this memory is accessible with a 16-bit register. So that's why we can combine the registers. So two 8-bits will make all the memory callable. That's what I'm looking for. All right, let's talk about the screen for a moment. 256 times 192. Also, we have a border around it that we need to emulate. Now, I couldn't for the life of me figure out how this worked back then. So a friend of mine, a coworker, he wrote that part for me. He actually wrote it from memory because, it works like this and that. And it's quite complicated if you ask me. So what you do is that if we fill the Spectrum memory from 0 to whatever it ends on, it's going to look something like this. So it actually is rendering the line 0, 8, 16, 24, 32, 40, 48, 56, 64 in the top, the middle, and then the bottom. It's really odd. I have no idea why. If you search for it, it's because the ALU, the screen processor, basically makes it access the memory faster. I don't know why, but that's the way it works. So when it comes to the colors, we have black, blue, red, magenta, green, cyan, yellow, and white. And then we have a bright version of this as well. Or as I saw them, 15 shades of gray. Then on top of that, so you saw the pixels rendered, right? But it's not pixels. It's actually whether or not we should use paper or ink. I really love how they name these things. So paper will be the background color, and ink would be the foreground color. And then you followed by those pixels, if you will, you would get the attributes. And you can set the attributes 8 by 8 pixels, so in quite a big square. You would have the ink color, you have the paper color, whether or not you should use the bright colors, and flash would switch between the two. So if you go back here, so basically just saying that all of these black colors here are ink and everything white is paper. So if we add the attributes to this, it would look something like this. And one of the problems with just setting 8 by 8 pixels is this. You see that you have color clashes here. This was probably supposed to be purple because the mountains are purple, but instead we got these color clashes. Now I mentioned the border. The border is configurable in the emulator. Basically, well, you can set the border color, the border size. And while you're loading a game, for example, you might remember the stripe things. All of that is actually timing. So it's basically if you set a specific value on the out port, it's going to switch the colors. So the blue and was it red colors was while loading the header of the tape, and I see nodding, so I'm getting this right. And the yellow and blue is actually the data segments of that. So it's all about what it outputs on that specific port. Now, when it comes to in and out ports, I solved it I have a list of an I input and an I output. Probably not the most performant way of doing it, but an easy way to add stuff to the emulator. Now, the keyboard was a rubber one. It was quite horrible to type on. I'm guessing that's why so almost all, or all commands has a keyword. So if I were to type load, for example, I would just type J and it would type out load for me. So don't type a lot of stuff. Don't have to. And this is one of the things that I need to do platform specific for each of the different emulators. And this is actually, this slide is done in PowerPoint completely. I haven't done it, I found it on the internet. So someone has done this completely in PowerPoint. Awesome. So what about output? Well, sound is an output. So to understand the sound, I didn't know about how a speaker worked back then. So basically what it is, the beeper is a 1-bit beeper. So it's basically full on, full off. But what is happening is that you pull back the membrane of the speaker, that's 1, and you release it, that's 0. And the frequency of you doing that makes the sound. So it's all about manipulating the bit 4 of the output port. So it will look something like this. But basically, if the port changes, we're going to turn it to 1. We're going to wait for it to turn to 0 and fill the gap with whatever it was, and then turn it off. And we're going to do that in the emulator's case, 48,000 kilohertz. So we're going to make sure that we get that out. And this is also one of the things that we need to do platform specific, but as long as we can get out that sound wave, you're going to be quite fine. So what about the challenges of doing all of this? Well, converting hardware to software, what does it mean that there's a resistor between the mic and the ear, for example? I have no idea. Well, it means that everything in the ear also comes out in the mic. No, actually the other way around. But it also keeps me on my toes because we need to kind of eliminate the garbage collector, because if the garbage collector starts collecting stuff, you're going to get you're not going to get the best experience. It's going to be very spotty. So I use temp values or as fields and stuff like that. I don't want to do any allocations, unnecessary allocations. And of course, working with bit shifts and all of that, that isn't something that I usually do. Tests super important. I found the Fuse emulator had a lot of tests, so input value, you would run the emulator for a amount of T states, and then you have output values, you can test all of that. So all the methods, all the operations actually has a test in here as well. So in 2006, 2007, around there, the first version of the emulator was running on Xbox 360. And this is the only image I have from that. I should actually try to dig up one of the 360s and see if I can get it working. But you saw the on-screen keyboard and all of that. It was working. But someone beat me to it. Someone released an Xbox 360 emulator already. So I'm kind of like, yeah, I'm not going to do. I was not the first for this, so I'm going to leave it. And the sound didn't work 100% back then either. And this is some other images from there. Now, I mentioned that a lot of things in my life you can track back to the ZX Spectrum. So this is a cake that my wife made for me. So in 2008, I had a horrible day at work. I came home, I think it was close to 1 a.m. We had a bunch of stuff that we needed to do. But that day, XNA had dropped a new version. This version I could develop for the Zune. Anyone had a Zune? Do everyone know what a Zune is? Not all of you. So the Zune was the iPod killer. Yeah, the Microsoft iPod killer. So my wife comes into the office and I'm still working. He says, "Are you still working?" Yes. What do you ask? What are you doing? Okay, so hear me out. XNA just dropped. I just have to try and get the emulator running on my Zune. And it worked. It took like an hour or so. Got it working. My Zune is dead now. Still have it though, because reasons. But this was also one of the things that my wife used to send into Microsoft Tech Days, because they had a competition, Geek of the Year. I'm not sure if I'm proud or not. But a couple of years later, back in 2011, I got the prize as Geek of the Year. And that was one of the things. The Spectrum emulator was one of the things, definitely. But this opened a lot of doors, because suddenly Microsoft Sweden knew who I was. And just, I think it was the same year, I was on stage at Microsoft showing off an application that I made, a Stockholm Travel for Windows Phone back then. And one of the speakers was like, Jimmy, you should show the emulator. And yeah, sure, I can do that. So I showed the emulator, and I got the only spontaneous applaud of that whole day. And I thought, that kind of feels good. I like that. So that kind of made me think about, public speaking. Maybe I should try that out. So that was kind of the start of all of that. Now I got more devices. This is Gadgeteer. Got it running, slow as hell, but it did work. This is running .NET Micro Framework. With, I think it was the Mango update, we got augmented reality for the Windows Phone. So I created this 3D model. You saw it in the beginning as well. I had no experience in 3D modeling at all, but I got it working. But I mean, this is cool and all. But what if I could run the emulator as well? Oh, it's actually sound. Sorry about that. So check it out. It's an emulator running in augmented reality. And in just a moment, anytime now. So it got it working in augmented reality as well. Now, in 2011, a UK company called Elite contacted me, and they said, you have an emulator, we have games. So could you create a couple of Windows Phone apps for us? Now, the sound was a little bit off, so I exported everything to Excel, tried to compare, trying to figure it out, and I did after a while. So the year after, Manic Miner for Windows Phone was released. I think I did Chucky Egg for Windows Phone as well. And I continue working with the emulator. So I did one for Windows 8. I did one for Windows RT. I actually had to convert everything to C++ because it wasn't fast enough with C#. So I think I did 101 games for Windows 8 with the emulator. Next year, I did a 360 version of Manic Miner. It was a really interesting process because all of this was, there were other developers testing your application, and they were like, yeah, so it doesn't work. If you start the game and you yank out the controller, the game crashes. I didn't try that. So, well, it got released after a while. But if you know the story of Elite, Elite is kind of famous for not paying their developers. I'm one of them. I did get paid, but not the full amount. But yeah. More devices, right? Did anyone get the Agent Watch? No? That's true. That's true. So it was Kickstarter. And they got an emulator out. So this is the emulator, inland emulator. Kind of cool. And as Jessica said, no one got it. But I've been out doing talks like this. I've been traveling the world, doing all of these different events. So Jessica and I, we started a podcast called Coding After Work. And we later expanded. We have a Twitch channel. We have a YouTube channel. So please check that out if you want to hear some awesome guests, I guess. But I asked my friend, I wanted something cool, some kind of intro music. So I asked my friend, the same guy that did the Spectrum screen, could you do something cool for me? And he knew that I like Kraftwerk. He knew that I love Depeche Mode, Speak and Spell era. And well, I obviously said, well, I want vocoders because everything gets better with vocoders. But he snuck one more surprise in there. So this is inside of the intro music. I think it's stopping now. There we go. So this is the micro curve speech. Did anyone have one of those? Yeah, one. So this is hardware that you can connect to the Spectrum. So each key would actually sound out the letter. And I remember, I sat by the computer, J-I-M-M-Y, J-I-M-M-Y. It was so cool. So he added that into the mix as well. And talking about Spectrum or development in general, in 2014, I became a Microsoft MVP. So that's kind of also goes into the mix here. Now, I didn't do a lot of emulation for a couple of years, and then the HoloLens came out. Woo-hoo. So, of course, I took the emulator, I rewrote everything in Unity, and this is the emulator running on a HoloLens. Can you tell what my favorite game is?
You completed it.
Oh, this one I have. I found this really, really cool. All right, but we're here to talk about Blazor, right? So in 2018, the first version of Blazor came out. That's what Blazor Server. And that was not a good platform to create any emulators. But I showed it to my colleague, and he was like, just simple select box back then, check it out, what's happening. And he was like, this is what we're going to do. We're going to do this. This is the new framework that we're going to use. So 7 days later, it was running in production. Very, very simple, just a select box, but still, that was the route we went. So being a fan of Blazor, I wrote a book about Blazor. I wrote another book and a third book, and we're talking about a fourth book. And these are the only Blazor books with raccoons on the cover. Super important. I've also done a course for Dome Train. Actually, I've done 2, and I'm working on a 3rd. I mean, all of this is from that moment, my ZX Spectrum days. So when I started with Blazor and the ZX Spectrum, I wanted to play some sounds. So I'm using the audio context. So basically what we're doing is that we are buffering 20 milliseconds of sound, sending it over to JavaScript. JavaScript is playing the sound. And we need to do that 20 milliseconds of sound every 20 milliseconds, so to not get any interruptions. I actually have a contribution by a fellow MVP, Christopher Strube, who is, he made an audio context library. I have a PR, but I haven't accepted that because I'm a little bit of a chicken, so I didn't want to do that just before I did this talk. There's another library made by Junichi Sakamoto, also a fellow MVP, that I can connect my gamepad to the emulator as well. And it's mapped to the Kempston joystick interface. So it also gave me the ability to play around with devices. The keyboard is a little piece of JavaScript that is capturing all the key presses, and then Blazor is asking, so what buttons are pressed right now? Now the screen was interesting because, I mean, it's 256 plus the border, 192 plus the border, and times 3 because RGB. That's over 200,000 bytes that I need to kind of send over from Blazor to JavaScript and then render the canvas. And back then, interrupts was very, very slow. So what I did was that I'm allocating some memory. I am getting a pointer to that memory. I'm sending that pointer over to JavaScript and then releasing it. So the JavaScript is actually accessing that pointer in memory. That's the way I did it in the first version. But in .NET 9, they removed that ability because there are better ways to do it. So I thought, would it be possible to do it even better? So since this is running WebAssembly can run WebAssembly. So there is a library called Skia, which is made by Google. It's used heavily inside of Chrome, for example. It's Xamarin or Maui is using it. And they have compiled that C++ or C code to WebAssembly. So that's kind of cool. Now, why is this important? Well, when it comes to the ZX Spectrum, we are doing around 10,000 assembler instructions per 20 milliseconds. We need to generate 20 milliseconds of sound. We need to share and decode the screen. And again, less than 20 milliseconds to update the screen. So we were pushing the boundaries here a little bit. It was quite slow in the beginning. But thanks to ahead of time compile, we could get it to almost native speeds. We got a little bit bigger file size, but still, it was quite good. So back to Skia. So I had an option that I could take all of the data and send it to JavaScript, let JavaScript render the code, but I kind of like not working with JavaScript. So I found Skia, and with JavaScript, it took around 3 milliseconds to kind of get the screen, push it over to JavaScript, render the screen, around 3 milliseconds. But if you have 20 milliseconds, 3 milliseconds is quite a lot. So with Skia, I was expecting that this is going to be slow. I'm not going to get that performance out of there. I mean, even though C# is calling WebAssembly, I'm probably not gonna get that performance. But it actually, it went from 3 milliseconds to 0 milliseconds. It's super, super fast. I'm sure it's not actually 0, but the timer said 0. So it's super, super fast doing it that way. So I'm just saying, you know what? I have this bitmap, render it, and it's doing that for me. Super fast. So, I mean, you obviously want to see the emulator, right? So zxbox.com. Let's pull it up. See if I can. Yeah. So while I am presenting, for some reason my computer is super slow. So the sound is going to be a little bit off, I think. The cool thing with Skia, you see that it's pretty crisp here. I could add shaders on top of that to get that CRT feeling. I haven't done that yet, but I could, which is kind of cool. So if we scroll down here, can load Manic Miner. I'm not gonna play that the whole time. There we go. It's actually working quite nice today. And again, Xbox controller if I want to. Can jump around, do all of this stuff. Woo. Well, so I've done Manic Miner. I mentioned for Xbox 360. I've done it for Windows 8, Windows Phone. Well, for HoloLens, all of these different platforms. And I have still never finished this first level. I'm not sure it's possible. I have a colleague that calls me on Teams from time to time, and he's like, hey, look at this. Sharing a screen, and it's just finishing the level. Have anyone finished the first level? Finished.
Decompilation, do you get extra life? Is the boot, and that really helps.
So I've played the game with unlimited lives. I've still not finished that level. Let me pop back. So if you do finish it, please let me know. Or don't. I don't know. So the future, what's the future like? Well, I would love to create the current microspeech. That is way beyond my capabilities at this point, but I would love to do that. Did anyone have one of these printers? Yes, some of you. I never had one. My brother had one. And I still can imagine that I can smell it. It was kind of burnt aluminum. It was horrible. And I really want to be able to emulate. I think it should be quite easy to emulate this. Not the smell, but the emulator. I would love to do that. That would be so cool. So the ZX Spectrum is the reason that I wanted to become a developer. It's the reason that I became a developer. It's the reason how I met my wife. It was the reason I became a public speaker, an MVP. It's the reason I got to travel the world, be here in London with all of you amazing people. So thank you so much for being part of my journey, and I'll stick around for if you have any questions. Talking about sticking, I have some stickers over here as well, so please grab some of those. And if you have any questions, please reach out. Thank you so much.